Class. Today we are going to learn how to analyze and design a two-story residential building, like your own building. You can design and analyze this. Okay, so at first open STAAD Pro, click on new project, click on space, give a file name, own building. Next, select add beam and finish. So we have to have a drawing first. So here is the drawing. It is a two-story building, ground floor and the first floor. In the ground floor there are 2 rooms, 1 garage, toilet, kitchen and dining and stair. In the first floor there are 3 rooms, 1 toilet, 1 kitchen. Now we have to draw layout plan and roof beam plan for the drawing. Now column to column beam are the mandatory. If you have wall in the middle of column, then we have to give a beam. So here we give a beam, and this is for the toe beam, for the starting where the stair is starting. The stair will be starting from this beam. That's why this beam has been provided. And in the STAAD Pro we are going to need the center to center distance from each column to column. So here is the center to center distance, foot and also meter, the dimension. Now we have to draw this drawing into STAAD Pro. So we are going to select from this column. This will be our 000 node. So go to STAAD Pro, create a node first, select and close the snap node beam. Select the node cursor, select the node, copy the node from your keyboard, Ctrl C and paste Ctrl V. Now see the drawing. In the X axis, this is the X axis, this is the Z axis. I told you before. In the X axis is 3.9 meter, then 3.33, then 3. In the X axis 3.9. okay, select the next node, copy the node, paste the node in the Z axis 3.3, and the next one is 3. Four nodes are created. 1 2 3 4. In the Z axis, first is 4.1 meter and second is 4.2 meter. Select the all nodes at a time, copy the node, Ctrl C, paste the node, Ctrl V. The Z axis 4.1. okay, then select the nodes, copy, paste in the Z axis 4.2, 4.2. okay. Now these are the column. These are the column, and it has the foundation. not the beam has the foundation. Beam don't have foundation. The load transfer from float to beam, beam to column, column to foundation or footing, footing to earth. So we have created the column and then we are going to create the beam. So these are the foundation. Copy the node, Ctrl C, Ctrl V, paste the node. Now we are going to give the value, that is value is the GL to PL value. GL means ground level, PL means plinth level. This value is 1.5. It is the foundation depth. These nodes are the footing of your building, and this node will be the column and the connecting beams. So select this node, go to view selected object only, to create the middle beam or the extra beams. So for the extra beam, you have to create the node that is from this distance to 2.0, from x to z, positive x to positive z, 2.0. Select these two nodes, copy, paste in the z direction. It is 2.0. Okay, nodes are created and there are 1.7 from positive direction. These two nodes, copy, paste, 1.7 in the z direction. Now we have to join the node by beam. You can manually select the node to node, or you can go to the easy way, that is select the nodes, go to select geometry, connect beam along x-axis. All the nodes or all the beam in the x-axis are created. Similarly, select the all nodes, go to geometry, connect beam along z-axis. Easy. Now display whole structure by clicking that. Select the node, and for selecting the node and beam, you have to select beam cursor. Select the beam and copy the beams and nodes, Ctrl C and paste Ctrl V from the y axis. The room height is 3 meter, that is floor to floor height. Okay, the single story, again Ctrl C, Ctrl V, y axis 3. Okay, for the multi-room, select the top beams, go to select, go to view selected object only. These the 4 column are going to be the multi-room. This portion is going to be the multi-room, that is the middle 4 column. So select this 4 node and copy the node, paste in the y-axis. Boundary room is 2.4, okay, in the y-axis. Now display whole structure. These 4 nodes have to created the beam. Select the 4 node, go to geometry, connect beam along x and z axis. And we have to create the y-axis. For that, go to top Y, select only the column. If you select all nodes and go to the geometry and create beam along to y-axis, then it will also create here as a column. So select node cursor, select the only column nodes. Column nodes are selected, then go to geometry, connect beam along to y-axis, go to 3D rendered view. You can see the 12th number of column are created and the boundary room. Okay, now we have to provide the support. For that, go to support page, or you can select here support, click on create, select fix support, add, select the support, go to front view, select the all nodes you want to give the support, and click on assign to selected nodes, assign, yes. Support are given. Then go to property page, select property page, go to define, material is concrete, it is a rectangle structure, rectangle column, that is 250 millimeter by 250 millimeter. That is 10 inch by 10 inch. In meter, 0.25 by 0.25. Column, for the beam, you can see YZ is the depth, or you can say height, and 25 is the width. So for beam it is 30, means 300 millimeter. Add and close. Okay, now for assigning the property in the member, go to front view, select the node individually, or you can assign the column by single time. Select the column property, go to select beam parallel to y-axis, these are the column, select the section and click on assign to selected beams, assign, yes. Column property are given. Now the beam, go to top Y, if you want to provide same beam property, then select the beam by beam selecting the node cursor, just checking the beams. Now all the connecting beam to column are selected. This property is 0.30 into 0.25. Click on assign to selected beams, assign, yes. Now the extra beam, select the extra beams, and select, select the extra beams, select the property, click on assign to selected beams, assign, yes. Now just check any property are missing from the member. For that, go to select by missing attributes, select missing property. See, one is missing. Select the missing property, select property, assign the selected beams, assign. All the property are given. Close. Now you have to give loads. Go to load page, select load case detail, click on add, select primary, loading type dead, title dead, add live, go to dead, click on add, self-weight load. Self-weight factor is -1. -1 means the 100% load. Click on the add the self-weight, go to member load, member force, that is uniform force, W1 for the beams, that is the 250 millimeter wall, that is the outer wall are the 250 millimeter. So those load will be 16.5 kilonewton per meter. Add, and for the middle beam the load will be 9.3. Add, for the parapet wall on the roof beam, the parapet load will be 3.1. Add, all load will be minus because it is downward. Change, just double click the load and give minus. Select the self-weight. Self-weight goes to the whole structure, so select self-weight and assign to view. Assign to view means the whole structure. Assign, yes. go to front view, select the structure, view, select object only, and select the outer beam. Minus 16.5 kilonewton. Click on assign to selected beams. Assign. Sorry. This is the roof beam. There will be no wall in the roof beam. Only parapet wall load. Assign to selected beams. Assign. Yes. The parapet wall load goes here. First the inner wall load. View selected object only. Select the load. Assign to selected beams. Assign. Yes. Whole structure. Select the roof and the mounting room. Parapet wall load. On the beam load. Okay. Now go to live load. Click on add. Member load. Sorry. Floor load. Minus 2 kilonewton. Now for the floor load, you have to provide the Y range. That is here. Y value is 1.5 to 7.5. 1.5 minimum, 7.5 maximum. Direction global Y range. Add for the mounting room load. Y is 9.9. It is 7.5 to 9. Sorry, maximum and minimum will be the same. 9.9. 1 kilonewton. Add, close. For the floor load, we're going to date, add, and give the floor load by manually. Floor load is 5.6 minus 1.5 to 9.9. Add, close. All the loads are given. Now we have to analyze the structure. For that, go to command, analysis, perform analysis, no print, OK, analysis, run analysis, save. It will take few seconds. There is no error, no warning. Okay, so all are good. Now go to design. Here in the left you can see design, select design, select your country code. For me it is IS 456 Indian code. Sorry, select the concrete design and then concrete design. Current code, select IS 456 and then go to the parameter, select parameter, select the clear cover, compressive strength, main reinforcement, shear reinforcement, select parameter, OK, define parameter, clear cover 0.025 30 for beam and for 40 for column. Compressive strength, it is M20, 20,000. Add yield strength 415,000. Add shear reinforcement 415,000. Add, close. Now select the parameter and assign to the structure. Clear cover 30 mm is for the beam. Select the cover, go to select beam parallel to X, select beam parallel to Z. All the beams are selected. Assign to selected beams, assign yes. For column, go to select beam parallel to Y axis, assign yes. For compressive strength, goes to the whole structure, so assign to view. Same is the shear and main reinforcement. Okay, then go to the command, design beam, add design column, add. For beam, select design beam, go to select beam parallel to X, select beam parallel to Z. For column, go to select beam parallel to Y. Now we have to analyze this. Go to command, analysis, perform analysis, no print, OK, analysis, run analysis, save. There are also no error and warning, so our design is perfectly okay. Select view output file and result concrete design. You can have the result from here, or just selecting the beam, you can have the concrete design. In the top bar there are two 12mm rod, and in the bottom reinforcement there are two 10mm, and column 4 number of 16mm bar. It is also 4 number of 16mm bar. In the beam top reinforcement up to mid span, it is 10mm dia bar 3 number. In the end portion it will be 2 bar 10mm bar. In the bottom portion 10mm dia 2 nong bar. Okay, you can have the axial force, shear force in the y direction, torsion, bending moment, bending Z, bending stress. All the value is here, and deflection. Okay, so that's it. That's how you analyze and design your own building. Okay, if you have any problem, comment on the video or mail me. I will reply you as soon as possible. So thank you for watching, guys.